What if the next big thing isn't a thing at all? It's lots of things, all waking up. Becoming part of the global phenomenon we call the Internet of Everything. Trees will talk to networks, will talk to scientists about climate change. Cars will talk to road sensors, will talk to stoplights about traffic efficiency. The ambulance will talk to patient records, will talk to doctors about saving lives. It's going to be amazing and exciting, and maybe, most remarkably, not that far away. The next big thing, we're going to wake the world up and watch with eyes wide as it gets to work. Cisco, tomorrow starts here.
Ladies and gentlemen, please welcome Senior Vice President, Security and Government Group Cisco, Christopher Young.
That's pretty amazing, isn't it? And the future is a lot closer than we all might think. Philippe even talked about it in his speech a few minutes ago. Today, rapid changes in the world we live in, driven by technology trends, business model changes, and market transitions, like that Internet of Everything video we saw, are profoundly impacting all of our networks, data centers, and the overall IT infrastructure. Today, I wanted to explore with you the risks and the opportunities associated with software-defined networking, which is really about the changes in the underlying fabric of our next-generation networks and data centers. This can be a better way to secure our most valuable applications, our users, our data, and think about how we can do that today as well as in the future. One question I had before I got started is how many, by show of hands, are actually planning in your organizations today or working on delivering some form of software-defined networking capability in your infrastructure? Just a couple, a few of you. That's sort of what I thought I'd get as a reaction. So one of my goals for today is to hopefully give you some education on software-defined networking, some of the opportunities and risks associated with this massive technology trend that's going to impact us quite significantly. But let me start with one of the facets of our lives that's changing pretty rapidly as a lot of the technology changes around us. And it's something that everybody in this room cares about: jobs. If you think about it, jobs like social media marketer, sustainability officer, or data scientist, they didn't even exist 5 years ago. And just on a recent trip to Washington, D.C., I was driving down the highway and I saw a billboard for a brand new job that's relevant to everybody in this audience: cyber warrior. That certainly didn't exist 5 years ago. Think about what jobs in the next 5 years are going to look like. We also have to consider the growth of the internet itself. Today, much of the growth is driven by the explosion of mobile devices, but will increasingly be driven by these connected things like the devices we saw in the video. In 1984, there were only 1,000 devices connected to the internet. In 2008, there were 1 billion. And we estimate that by the year 2020, there's going to be 50 billion devices connected to the internet. Now, as the number of the connections increases, so too will the number of applications. Application development is happening both in the cloud as well as for the cloud, and it's exploding. Now, public cloud applications, interestingly enough, are the ones that are really leading the charge here. You know, it's great to see that a lot of our CIOs are planning to adopt cloud-based applications more and more over time. But the reality is that most organizations, most CIOs are being dragged to the cloud by their users and their lines of business who want to run their applications in the cloud, develop for the cloud, or get application as a service models. Now, a further extension to these trends around mobility and cloud is the Internet of Everything. There is rapid growth in the number of things connected to the network. A great example that I experienced personally just recently, I got a chance to go out and test drive that new Tesla Model S sedan. And I noticed immediately this thing had a highly sophisticated onboard computer, full-on browser, and 3G connection. And then a couple weeks later, I saw the blog from Elon Musk about all the different logs that he was able to pull from a test drive that the New York Times reporter did. Now, these things like cars are going to increasingly add capability, context awareness, more processing power, even more energy independence, like we're seeing in electric cars today. This is the Internet of everything. Effectively, it's a network of networks where billions or even trillions of devices are going to connect to one another and ultimately create what we see as unprecedented opportunities, but they're also going to create a lot of risk. So as we move to this era of the Internet of everything, the network itself is going to become increasingly programmable with APIs and new forms of analytics at all layers. However, with the advent of a lot of these new capabilities, we're also seeing a new paradigm created for security. And it's what I like to call the any-to-any problem. And what I mean by that is you can have any user on any device going over any type of connection to any application that could be running in any data center or any cloud. And if you're an enterprise or in a public sector organization, increasingly your users are going to connect to applications to get their jobs done without ever directly coming through your controlled network. Now, regardless of how or where our users are connecting, we all as security professionals have to provide the right level of inspection of transaction and the right level of protection against our adversaries or the threats. And our basic security and compliance requirements, they don't change. But the playing field that we're all working on top of is changing pretty rapidly. Now, these changes to the network as well as the data center that underpin this any-to-any model are best described by what the industry is calling software-defined networking, or SDN for short. Not to be confused, by the way, with self-defending networks, which is what Cisco talked about a few years ago. Now, each vendor you're going to find is going to have a little bit of a different definition of software-defined networking and how the networking is changing. You'll hear software-defined data centers, software-defined storage. Cisco refers to this as application-centric networking because we're introducing programmable APIs that focus on distributed control plane intelligence, I'll explain this a little bit later, so that applications can get value directly from the network itself. So why is the industry embracing this? And why is this important? And I can use a lot of technical terms to describe for you why SDN is valuable, but the way I like to think about it is a lot simpler. Think about it this way. SDN is going to bring the cloud model that we're all starting to focus on more and more and put it on steroids. Here's what I mean by that. We're going to lower operational costs. We're going to more quickly and scalably deploy applications and network services. We'll be able to do more cloud bursting, which is about being able to deliver flexible compute on demand. Now, if you think about it, today's cloud providers already tell you they have a lot of these capabilities. But what they don't tell you a lot of times is that the network can actually be a bottleneck to realizing the full value. So if you think about it this way, SDN is really the last mile to unlock the full value and benefit that we expect to get from the cloud. But we get additional advantages with software-defined networking. One of those is that ability for applications to interact directly with the underlying network infrastructure in ways that we're not able to do today. One example, applications will be able to query the network for location or identity of users to be able to manage quality of service and ultimately be able to deliver targeted content down to a user or device level. And ultimately, from a security perspective, this model is going to deliver us powerful new ways to both detect as well as defend against attacks by being able to tap into the network's capabilities for high-scale visibility and enforcement. Now, hold on. Before I go too far, I want to take one step back and describe SDN. I mentioned that kind of scalable controller model a little bit before. This behind me, I think somewhere, should be a picture of a network. And if you can see, there's lots of devices on the network, devices that we use all the time, laptops, desktops, servers, mobile devices, printers, you name it. as well as underlying networking devices like switches and routers, sorry. Now those switches and routers, that underlying network architecture, has 3 architectural layers in a device itself. The first layer is the management plane, which is where we set policy in the device. Second layer is the control plane, which makes decisions about where to send traffic. The third layer is the data plane, which actually acts on those policy settings as well as traffic management decisions that are made by the other 2. And software-defined networking is the abstraction of these layers so that we can dynamically allocate the resources that have been individually controlled in the past by each one of the layers. This model introduces expanded APIs so that network administrators can now have programmable and more central control of network traffic without requiring them to have access to the individual devices upon which the network is built. And through SDN, we'll get far greater convergence of the 2 different domains between the network architecture and the data center infrastructure, which have historically been disparate. And by doing so, we're going to allow applications to operate more seamlessly and be able to move between and among different clouds. And then if you kind of zoom out from the network device itself and look at it from the perspective of an entire network, you can see how we can easily get control of distributed functions in a massive scale across all of the layers. So we're not just abstracting at the device level, we're doing so at the entire network level. But it's important to understand that with software-defined networking, we're experiencing an evolution. And what I mean by that is it's not going to require a forklift upgrade to an entire network architecture in order to get the benefits. For example, only a simple operating system upgrade is going to be required on most existing devices today to get the value and enable SDN. This is, and most importantly, going to be the next evolution of programmable networks. Now, so for anyone who was here with me last year at the RSA conference in the Cisco keynote, you'll know the classic security question that we have to ask and answer. Do we lock it down, or do we free it up? Now, the answer to that question is going to all depend on your perspective. You can look at these changes in one of 2 different ways. You can say to yourself, look, my life's going to be a lot harder now. I got more to protect. I got these controllers. I'm worried about them. Or you can look at it on the other hand, and you can say, now I've got an opportunity to do something different. I can change the game in security and do it better than we did it before. Now, there's a reality to that first thought, because we will need to secure the network differently in an SDN-enabled architecture. Because SDN's power is in its ability to expose information and control of many devices that used to be individually autonomous. And creating this external control point results in effectively a centralized place now where our adversaries can focus if they want to get control of the same resources. For example, you can imagine that we're now more vulnerable to a man-in-the-middle attack, which can happen if an attacker can impersonate either the controller or the switch itself. But with SDN, we're opening up new APIs on devices. So if someone does get a hold of the control logic and there's weakness there, they can get control potentially of the entire network. And by centralizing control and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one malicious actor would be much, much greater than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level of authorization, granular access and programmability of the network, the impact of one accident or one would be much, much greater. One malicious actor than the impact on the network in today's world. So it is critical that we secure SDN as it can affect the behavior of an entire organization's network. What I mean by that is we're going to need authentication, the right level